Hello, my name is Philip Penland, and welcome to my Lopes Talk, which we are entitling Who is Actually Doing the Science? So imagine you're walking past two science classrooms. In both rooms, students are gathered in groups. Both have styrofoam balls representing the moon. Both are using light to represent the sun. Students are talking, moving around, participating. And from the hallway, both classrooms look like active science learning. But I think there's a more important question we should be asking. Who is actually doing the science? That question is what separates the two moon phase lessons presented in these vignettes. In Miss Sheridan's classroom, students are certainly active. They discuss what they have already known, work collaboratively, and physically model the phases of the moon. But before they began, Miss Sheridan had already explained why moon phases occur, shown them the current models, and given each group a diagram to reproduce. Their investigation confirms an explanation that they'd already received. The lesson eventually leads to flashcards and then a quiz. Now, walk into Miss Lee's classroom. The materials are surprisingly similar, but the thinking is incredibly different. Her students have spent weeks observing the moon and collecting data. They have questions they still cannot answer, particularly why the moon appears to change shape as it orbits Earth. Instead of answering that question for them, however, Miss Lee helps students figure out how they might investigate it themselves. They create models, they make observations, they draw explanations. Then something especially important happens. They compare their explanations to those of other groups and discover places where they disagree. And Miss Lee doesn't treat the disagreement as a problem. Actually, she turns it into science. Students have to return to their evidence, defend their thinking, revise their ideas, and eventually develop a consensus explanation. This is where constructivism and inquiry fit together so naturally. Constructivism suggests that students do not simply absorb knowledge handed to them, they build new understanding by connecting experiences and evidence with what they already believe, sometimes discovering that their original thinking needs to change. This does not mean that the teacher disappears. In fact, I think inquiry can require even more intentional teaching. Miss Lee is constantly guiding the investigation. She asks questions, provides new materials, helps students focus their thinking, and knows when it's important to intervene. The difference is that she supports the thinking without taking ownership of the thought. Research on science indicates that education supports giving students opportunities to investigate phenomena, construct models, communicate ideas, and use evidence to develop their own explanations. But there is another reason this matters. Not every student demonstrates scientific understanding the same way. A student with an exceptionality may struggle with a page of vocabulary or a traditional quiz, while being remarkably capable of noticing a pattern in data, manipulating a model, drawing an explanation, or contributing an idea during a group investigation. Inquiry gives us more opportunities to actually see what students can do. This doesn't mean removing structure. Some students may need visual supports, vocabulary instruction, chunk directions, flexible grouping, or even additional processing time. The goal is to remove the barrier, not the challenge. Culture matters here as well. Students enter science classrooms carrying different identities, languages, experiences, and ways of thinking and making sense of the world. Culturally responsive teaching asks us to recognize these differences as resources rather than automatically interpreting them as deficiency. And teachers have to examine their own assumptions. If a student communicates differently than we expect, does that mean that they do not understand the science? If they struggle to memorize terminology, does this mean they cannot reason scientifically? Sometimes the barrier is not what the student can do. Sometimes it is what we have decided counts as evidence that they can do it. In my own science teaching, I want inquiry to begin with something students genuinely have reason to wonder about. I can still teach vocabulary, explain difficult concepts, model skills, and provide difficult instructions when students need them, but inquiry and explicit teaching do not have to be enemies. But whenever possible, I want students gathering evidence, testing ideas, talking to one another, disagreeing respectfully, revising explanations, and discovering that changing your mind because the evidence changed isn't failure. It is science. So when I look at these two classrooms, I do not think that the lesson is simply that one teacher used a traditional instruction method and the other one used an inquiry-based instruction method. The bigger lesson is that hands-on learning and minds-on learning are not automatically the same thing. Both classrooms had the models, had the moon, had the light, but only one consistently asked students to use those materials to figure out how they could figure out what they didn't already know. And when I plan my science instruction, that's the question I want to continue to ask myself. Who is actually doing the science?